Right, so my name is David Wheeler. I am a principal architect at Tembo, until recently, cloud Postgres provider, Postgres as a service provider. I've been a Postgres user since about 2000, for 25 years now, which is wild. I've been a contributor since 2008 to various stuff in the community, and including things like the PGTAP test framework for running unit tests in your database, Sketch, a database change management system, and the PostgreSQL extension network. And that the extension network is going to be kind of a linchpin of the conversation today. So a bit about PGXN. It was established in 2011. I started development in 2010. It is a distribution network for Postgres extensions to distribute the source code. So people make a release, they package it up, it gets released on the network, it creates nice documentation, a search engine, and all that. For any sorts of extensions and tools, it's not just create extensions, it's pretty much anything that's related to things to improve the Postgres community or the project. It provides full text search. There's a very nice documentation presentation. There's tagging, because tag clouds were a thing back in that day. There's also a command line client by Daniel Varazzo that can, find the best, most recent version of a particular extension on PGXN and install it, download, compile, and install it for you. This is what it looks like as of a few weeks ago. The homepage. The design has not evolved much over the years, although I did make it much more mobile-friendly a few years ago. So currently, PGXN hosts 422 extensions, close to 400 distributions, because some distributions have multiple extensions in them. There are about 470 users, and there are 2 mirrors. It's a fully static registry, so anybody can create a mirror through rsync. But this collection of a list of all the known public extensions on GitHub finds almost 1,200 of them. So it's not nearly enough that we have on PGXN, especially since it's sought to be like the source of record for finding publicly available extensions for Postgres. So when I started work at Tembo last year, we developed a vision for what version 2 of this might look like. The goals here were to be the canonical source registry, to really try to get it to that benchmark. Again, to have search and discovery for all extensions, because right now, even though there are a lot of extensions on PGXN, since it's not the source of record, people don't know where to go to find them, so they start using search engines and looking on GitHub and poking around and that sort of thing. I wanted to have sort of streaming and federation so that downstream services like registries could consume from it and know when new releases came out and automate building and packaging and reindexing and potentially doing other things like security scanning or what have you. To provide quality metrics and reports, again, to make it easier to understand what extensions were out there, who were using them, and kind of the general idea of the quality of them, so that it's easier for people to figure out what to use. Also, and this is a big influence from Tembo, was to kind of figure out a standardized system for binary packaging and distribution of these extensions. As I said, PGXN was for source code distribution initially. It didn't kind of want to touch compiling and building and stuff, and left that to mainly PGXS as the internal way to do it, and other systems developed since then. But we wanted to find a way, figure out if we could build kind of a standard packaging system to work across a lot of different platforms and OSs and configurations. So it would be multi-platform and multi-version. Most of the packaging systems that exist today are specific to a single platform and multiple versions of Postgres, and sometimes multiple versions of the OS, so there's a lot even just for those, and we were hoping to start small with a few of those and gradually add platforms over time. The idea was that whatever platform you were on, there would be a tool you would have simple and direct installation and package management of the extensions you need. So the general architecture for it that we came up with was to have the root registry for the source code distribution that would evolve from the current PGXN. Again, there would be a web UX that would evolve to provide more of the features like the reporting and quality metrics and all that sort of stuff. A command line client that would be more robust to be able to build lots of different types of extensions, PGRX, PGXS, anything else came along, Zig. This interactions service, as I was calling it, to kind of handle the streaming, it would publish, you know, like just an RSS feed for stuff, but it also could potentially have web hooks for trusted downstream consumers, so they could very quickly know of new stuff and build or take action on them. A system for stats and reports, so that those downstream systems could report successes and failures of buildings, and that would contribute to the stats that, you know, have indication of the quality of each extension. But any other stuff that we wanted to develop over time in terms of ratings or reviews or stuff of that nature. And then finally, packaging, which kind of integrates into all these pieces, because it needs to pull from the source code registry to build the packages. It is notified of new releases from the interactions, and the command line client would preferentially install the binaries rather than compile and install. So towards the end of last year, I turned my focus to packaging as kind of the newer and more difficult part of the equation, and also as an evolution of the stuff we were doing at Tembo with the trunk project. So I started working on some RFCs for PGXN. There's a PGXN, to release stuff on PGXN, you have a meta.json file which has a well-defined list of attributes you put in it. I started to develop a new version of that with a lot more information. A spec for JWS signing for releases. Currently, PGXN creates a SHA-1 hash as a simple checksum to validate stuff, and we wanted to get it into the purposes of JWS signing, so we have a lot more authenticity or verifiability for where an extension comes from, and it could extend also to extension authors signing them upon release. And then the binary distribution format, which I was evolving from thinking about Python wheel format and the Tembo trunk format, was another one of the RFCs. So feedback is appreciated on those. I've had a lot of really great feedback. But ultimately the goal was to have this meta.json file evolve to a place where it could drive the packaging systems so they could be fully automated for authors who took the care to, you know, put in the appropriate metadata to drive that stuff. And then I wanted to take the meta-driven packaging to create packages using this new format, the binary distribution format, which I called trunk, and distribute them via OCI. So there would be OCI images, artifact images that could be distributed. And a big part of this was because then you don't have to build a new registry system. You don't have to worry about federation. All this is part of OCI, really built into it. So a bit more about Metaspec v2. There's a new section there for contents that expands on what was there previously. So whereas before you just say this is the list of the extensions in the system, now you can say this includes these extensions or these modules or shared libraries. And then applications, so like PGTop is currently distributed on PGXN. It's nice to call it out as a different type of extension for the system. And this, I think I had like background work as considered part of modules there. To increase discovery, so in addition to the full text indexing and tagging to introduce classifications, this has been something that's been pretty successful with Tembo's trunk system. A lot of people actually use it to find extensions because they have these 16 or so categories. So if they know they want to find something for system administration or machine learning, they can look in the proper category. And then a way to specify dependencies that's not only just for other extensions as it is today with PGXN, but to say I depend on these particular features of Postgres, I require this particular type of pipeline for building it. There are variants that I can use if I'm installing it, if I'm installing it on a particular platform. And also external extensions, because a lot of extensions have other dependencies on shared libraries and whatnot. So here's a quick example of what the dependencies look like in the PGXN v2, where in this example we have much more fine-grained specification for what we require for a Postgres. So you can say it needs to have these particular features compiled into it, and it has to be within 12.0 or higher and no higher than version 17. You can specify the pipeline. So in this example, I'm saying it's PGRX. So we know it's not just PGXS or something else. And then the packages section is divided up into sections based on build phases. There's configure, test, and run here, but we also support build and develop phases for it. And these use something called Perl, the package Perl, which is a suggestion for a standard for representing package names globally. And the way they work is after the PKG, it says what type of package it is. So this says, okay, you know if you're installing something that this needs to come from cargo from crates.io. This other thing is generic, so it's probably going to come from your packaging system on your OS. And I was suggesting that for us, we'd say, in addition to that, we'd specify there's a Postgres type. So we say we need to have Postgres PG regress or Postgres a contrib data type or something like that. And then PGXN as a way to specify other extensions that you would want to install. As I said, there's also a way to map out variations. So you can say, okay, well, on this particular, if you happen to be building on Linux, then additional dependencies for packages at runtime, we recommend that you also install these. So there can be some variation in that. This came about in part when I tried to represent the PGML requirements for this, which are really complicated and vary a lot via OS. So I want you to imagine this. There are source code releases of all the known available extensions on PGXN. And its interaction services calls registry webhooks for downstream registries. So we're talking like Yum, apt, Homebrew, Pigsty, dbdev, whatever. They pick it up and they automatically can pull the new release and build the new packages. Now, some of them are going to have systems that won't want to be fully automated, but even so, the notification system would allow them to figure out the degree to which they do want to automate it. So the systems then install and configure the dependencies from the spec, so it knows, oh, for PostGIS, I need to install GDAL and these other dependencies from the OS. Then I can do the build and do the packaging. Right, and testing too. And one of the nice things is with the report system we want to have, it could report the results back to PGXN. Again, as a quality indicator, what OSs does this compile for? How successful was it? What packages are available? And we could list like the packages that are available on the website. So then you know, oh, I use PGDG apt, and it's there. So well, cool. And then a command line client that is aware of all these kind of aspects and picks the best possible package to install for your system. So last year I kind of imagined what this might look like. Maybe you have a search for the registry, say, oh, I want to know what sorts of things have JSON in them. I say, oh, okay, this looks like an interesting package. For JSON schema, it's got a pretty good rating. It's got a relatively recent release date. Let's try that. So they can do an install of that, and it will download, compile, or not compile. It's going to download the binary that's appropriate for the OS. Here, it knows that you're on Darwin with ARM64, so it's going to pull that binary and install it, and put the dynamic library in the right place, as well as, of course, the control file and the SQL files. And the other idea is that it is aware of what packages it has been responsible for installing, of course, so then you can say, hey, give me a list of all the packages that are installed, and you get that information. A lot of this, of course, is available in the view in Postgres itself, but this would extend to other types of extensions as well, like applications and modules. So you can see it's listed here. So that's kind of the vision of the goal that I was setting for the project. So let's talk a bit about the trunk package format that I came up with. Maybe it's a little confusing to call it trunk because that was what Tembo called their packaging system, but I liked it because it's like an elephant trunk, of course, and you are packaging your stuff into a trunk. Anyway. So what it is it's a file layout that's defined by the package format rather than by the operating system. This is in contrast to Debian and apt, which require full paths for the files that they install because they're tied very specifically to their OS. It allows the installation, therefore, on any compatible Postgres on your particular OS because it doesn't have to know ahead of time what the paths are. So here's what this looks like, the proposal for this package format. The name, first of all, has the name of the extension and its version in it. There's a plus sign, and then it says what version of Postgres this is built for, what platform it's built for, or what OS and the version of that OS, and then the platform architecture. And the cool thing, part of the reason I came up with this format is that's actually a valid semantic version of the whole string. So inside you have the typical kinds of release files that you have whenever you release a software package, your changes, your license, your README. And then it has another file with digests for every file in the system except for the digest file itself. So you can validate the files that are in there. And then there's a metadata file called trunk.json that has additional information about the system that you can't find just in the file name. And then, of course, in a PGSQL directory, it then has all the typical files that you have for an extension distribution. And they correspond to PGConfig directory options. The trunk.json package might look something like this. I kind of spec'd this up when I was working on a prototype. There's a package itself with the basic information about the package, the version, maybe the language it's written in, and what license it's under. Information about the Postgres against which it was built, including all the compile options. And then information about the platform, of course, for this particular package. And this one here being for Mac OS on ARM64. So then in addition to this, you take the idea, this is fully compatible with the OCI format. We just bundle the files into an image. It's basically just, if you're familiar with Docker, it's basically just a Docker image. You index the platforms in an index manifest. Is it an index manifest or image index manifest? Thank you, brain. So then if I have releases for different versions of Postgres and different versions of operating systems and different platform architectures, those are all separate images, and then the image index lists them all so that the client then can pull the index and know which one to install. And support for the platform in particular is built into the OCI protocol. This allows it to automatically, of course, install the correct binary for your OS and platform. Now we can extend this, as I said, to things like the Postgres version, potentially Postgres features, or even versions of, or if we get really abstract, CPU features and stuff like that, CPU versions, plus any other platform metadata. So the metadata for building an OCI image like this starts with kind of the fundamentals for an open containers package, where you're just talking about when it was built and what it is and what its version is, and where it comes from. Then you have the separate metadata for each platform. Here I'm showing Linux and AMD 64 and Linux and ARM 64. And then there's the custom metadata we'd use for the trunk format, the PGXN trunk format, that we would need to further distinguish packages for installing in a particular version of Postgres. So I made this demo of how it might all work. Actually, it's a prototype. I extended PGXS with an additional makefile that knows how to build a trunk package and then knows how to put it into OCI. So let's give it a run here. Hey, go. Why is it? Oh, there we go. So this is, I'm just doing a typical make to build this project. on Mac OS, and then I run make trunk, and so it then builds the package, the full package name here, and puts all the files in the proper location. And you can see here, this one here has, of course, the Mac OS dilib. So then I go into Linux and I do the same thing. I clean it up, I do make trunk, it does the typical compile, and then it makes the package here, and you can see it's now using, of course, the Linux package name for the trunk. So now we have 2 trunk files, one for each of those, and it is also, oop, damn it, I knew that was going to happen. Oh. Hey, there we go. Good. Right, there are the 2 trunk files. It also generates a bunch of metadata files that can be used to assemble the OCI image and stuff for each of the platforms. So I made this shell script that just takes those and uses the OROS utility to build the images and push them to a registry. So here I'm saying, this is what I want to build to go to my local registry with the extension package with this name and version, and hey, use this trunk for Darwin ARM64 and this other trunk for Linux AMD 64. So that builds that image and image index and pushes it up to the OCI registry. Right. So then another shell script then knows how to just pull the image from the OCI registry and install it. And this is, oh, sorry, did I? Oh, and it started over, awesome. So the basics of the shell script is that the shell script is running on Mac OS and ARM64 here, obviously, so it knows that. So it can make the request for the image index and pull the appropriate image with, oh my God. Just really wants to get to the dream there, doesn't it? No. So it pulls the image appropriate for this platform in this version of Postgres. So it's got the Postgres 16 for Darwin ARM64 and installs it in the proper place here. So it's installing the doc, the lib, and the share. Don't click in the wrong place, David. And then I exec back into Linux and I can do the same thing. And again, it knows to pull the image appropriate for this OS. It's running in Docker, so I had to use a different network name. But it's still the same image it's pulling, and you can see here that it has pulled it for Linux AMD 64, again, Postgres 16.3, and put the files in the proper location. So that's the general idea for kind of a generalized package for lots of different OSs and Postgres versions. Right. So that's the dream I had. You're not going to connect now, are you? Then late last year, Tembo started to have a pivot, and I was pulled off working on PGXN v2 so much, and I took over maintenance of the trunk registry for Tembo. And this was interesting because here there were over 200 extensions. There are now almost 240 that are there, and they hadn't really been updated in quite some time. And the way they were done is the way Tembo works is it creates a Docker image, it does the make, and then the trunk command line client runs make install and just does a diff to pull out the files that it needs. But the way it was doing a lot of that I found pretty funky, and things hadn't been updated to the latest version. So I wanted to get all that updated, which meant that I had to figure out exactly how to build and compile all these 238 extensions. Just on Linux for AMD 64, but still it was a really interesting exercise through which I learned of many challenges there that would remain to kind of the vision for automated building. There, all right, now it's working. So one is that there's often custom configuration. So for example, with PGRX projects, there's often a Rust package. It's not just whatever directory there's a cargo.toml in. That might be a workspace configuration, and then you have to figure out which of the projects inside the workspace, which of the packages inside the workspace is the one you actually want to build. So that, for example, is not included in the metadata right now. There's binary compatibility. We were building all of our extensions for Ubuntu 22. I started to build them for Ubuntu 24 and found that, of course, because there are different versions of libc, when I installed stuff from Ubuntu 24 on Ubuntu 22, it just did not work. There are different variations in packaging, so we were relying on apt only and stuff we compiled ourselves, but just anticipating, being able to pull dependencies for things from different locations. You have different kinds of packaging systems to pull those dependencies. Then there's the availability of dependency packages. Of course, not every packaging system has every dependency that every extension requires. In fact, there are quite a few of them, extensions that are fairly aggressive about the dependencies they have, on particular versions of Apache Arrow, for example, or libgrunga, and those are not provided by the packaging systems, which tend to be pretty conservative about what they will include. And then there are sometimes conflicting dependencies. For example, there's PG.DB, which patches and builds its own custom libduckdb. And then there's a DuckDB foreign data wrapper, which just uses the binary libduckdb that you can download from GitHub. These do not work together. I was unable to get DuckDB foreign data wrapper to work correctly with the library built by PG.DB and vice versa. DuckDB has since told me that they're going to add support for statically compiling DuckDB into their binary, which means that other systems could use the shared object library. But now we're just doubling the amount of stuff that's going to be loaded into your system if you need to use both. You probably don't, but it can be complicated. Another issue is that until recently, and I think it's still kind of the issue if you're building PGRX extensions, each one requires a specific version of PGRX to build, and it's installed system-wide, which means you need a clean build or to have all the versions pre-installed in order to build different extensions. And of course, some extensions have delays and fixes for things. I worked around this often in the trunk project by just using a little Perl magic and regular expressions to replace things that need to be replaced to fix, get PG URI to build on Postgres 17, for example. It was a really simple change. The packaging systems ship with patches for this purpose, and none of that supported by the current specification for PGXN v2. Then there's inconsistent build pipelines. It seems like no one uses CMake in the same way. There's a lot of variation. It's not standard like I know with PGXS, I can rely on make install check. But for something like CMake, it's like sometimes you run configure, sometimes you run it in this directory, sometimes you run it in that directory, and it's not standard across all of them. As just an example. And sometimes there are tricky things like there are separate releases for different Postgres versions, like with PG-Audit and PG-Hint-Plan. I actually was able to have PG-Hint-Plan build as a single extension on trunk by just changing the version of the source code it downloads. But PG-Audit is 4 different extensions, one for each version, and that gets a little tricky. And then sometimes there are extra build steps that are required, like bson requires, I think, a shell script to be run. Timescale DB also has something like that. And because they're specialized, they need to do a bunch of extra stuff. So these are all kind of barriers to this vision of being able to fully automate building packages for all extensions. and I'm sure this is just a subset of the issues. So these are not, I think, insurmountable. There are trade-offs to make. I can add additional configuration. I think it's reasonable to say add something to extend the pipeline configuration of the metadata files, for example, to say, okay, you need to install this package when you're building for Rust, or you need these options when you're building with Maven or whatever. But we need to balance it against exploits. I don't want it to turn into a shell script. I don't want this to be Apache Ant. So wouldn't want like direct commands to be in it. The way I started building the SDK for building packages using this metadata is to allow multiple metadata files. So if I'm a package manager and I get a new release of a particular package, I can have my own copy or patch of the metadata JSON to add additional stuff, and potentially I can add specific commands and configuration stuff in there. So there's always going to be some aspect of having to make manual interventions or one-time changes to things for your packaging system to address specific issues for specific extensions. Also key to this would be to report auto failures upstream so that they know that this stuff is happening and they can decide to fix it or not. We can send them patches. Why am I doing that? To address some of the issues of compatibility, we build separate binaries for each version of libc when we're building on Linux, or for each version of DAR when we're building on macOS, or whatever the equivalents are in FreeBSD and Windows and others. And then build the binaries for each platform. And just to start focus, we're going to start with Linux and macOS and grow from there. Add FreeBSD, gradually add other systems. So, of course, there's a risk of combinatorial explosion here. And I can see Alvaro's already chuckling over similar challenges. And, about this much point, I can imagine the PGDG packagers, Christoph and Devram, and kind of where they are right about now as they're listening to this. Or maybe they're saying, and then he said, upstream maintainers will fix their build failures. So I know the packagers are laughing at me. That's okay. I'm happy to be learning the same lessons that they've learned in the past in order to make stuff work in the long term. Right. So on that note, a cloud-native Postgres side quest. Extensions in CNPG, because cloud-native PG containers are immutable, of course, as typically in Kubernetes, any extensions that you want to use in CNPG have to be baked into your image. Now, Postgres 18 adds the extension control path patch, GUC, and this is to be a huge help. And Kubernetes 1.33 adds the image volumes, which is in beta. And CNPG, well, this would probably be 27, I think. It's not going to be in 26. They're going to add extensions to immutable containers. So here's how this will work. You're going to specify your CNPG cluster with the image name. Right now, you need to use PostgreSQL trunk 18devel so that you get the patch. There must be a beta one here soon. And then you just have a list of all the extensions that you want. So here I'm saying, I want to use pgvector, and it's using an image URL for this extension. Here it's using pgvector. This is actually an image volume reference, and this will be used to mount this container as a volume inside the container. So here's how it works when you make a change to your manifest. It triggers a rolling update, updating the replicas first, and for each one, each extension is mounted as a read-only volume in its own directory. The directory for this one example will be in /extension/pgvector. So that's where all the extension files live. The CNPG then updates the GUCs, so it updates extension control path in Postgres 18 to point to the shared subdirectory of pgvector there, and to the lib subdirectory of pgvector. And this is actually simplified because I think because both of these automatically will append PostgreSQL to the path name because it doesn't appear anywhere else in it, it might actually have to be different paths. Bit of magic there. So this works. They've prototyped it. Gabriel and his team at EDB have prototyped this, and it works very nicely. But there are some limitations, of course. One is that volumes are resolved at startup, so you have to restart the cluster in order to get your extensions mounted as volumes. Likewise, the GUCs also require a restart of Postgres in order to take effect. You can set them in a session, but as soon as you disconnect, they're gone. If you need them session-wide for your extensions, you need to restart the cluster. Also, you cannot use a single prefix for every single, for all your image volumes. Each operates like a full server prefix. So let's say, for example, that I want to install these 5 extensions into my image. So I spec them out in my manifest here. And when we deploy, CNPG will then update the GUCs to point to the directories for every single one of these. So the more extensions you have, the longer and more unwieldy these paths become in your PostgreSQL.conf. This makes me sad. The ideal in my mind is to be able to add extensions by patching the manifest, and for Kubernetes then to automatically add the volume without requiring a restart, and therefore to require no rolling restarts. So this would require image volume feature to change behavior and not require a restart. And also part of the ideal is that we wouldn't have to update the GUCs, that we could just have a single path, except shared preload libraries, for which we have no choice when it happens. But this requires a different file layout than we currently have for extensions in Postgres. But this would also simplify non-CNPG installs. So let me come back to this again to talk about, not again, not as a quasi-formal PGXN RFC, but in an RFC I posted on my blog, I was suggesting a way to approach this. So imagine this. There's a single search path GUC for extensions. There's no magic PostgreSQL suffix. It's exactly where the sysadmin or your manifest editor puts it. And each extension is in a directory with its name. And maybe versions, if we could try to address some of the issues with upgrading extension versions, maybe there's something there. I haven't really dug into that. But then within this directory, there are predefined subdirectory names for all the files that are necessary for the extension. So it might look something like this. We might have something called extension search path, and we say all the extensions live in /extensions or user local extensions. The layout of this might be if I go into, if I'm just looking at the list of files in the extensions directory, there's just a list of directories for each of the extensions that I have installed. So Postgres would need to be updated to then look for these directory names rather than the control files as it does today. So if we look in the directory for a single extension here, so in this example, Semver, we see that we have your control file as usual. So this is the new place that you would need to look for the control file. And then it has, as I said, predefined subdirectories for all the files that you would need for an extension. These correspond more or less to PGConfig names, but because they're static under this directory name, we can call them whatever we want. I think that I would suggest not having share as a name because it gets a little confusing with extensions itself. We can have separate subdirectories for docs, for libs, for the SQL files that are responsible for it, but also any binaries you need to install, man pages, HTML, include locale files. I think tsearch has a kind of thing it uses. I don't know if anybody puts tsearch files in extensions, but there are opportunities there just to standardize on what those names would be inside the directory. The cool thing is that the trunk format could then be made identical to this structure. So then the installation becomes really simple. Right now, it looks at directory names and compares them to PGConfig operations and figures out where to put them for a prefix. But now it becomes simple. If you have a prefix, you just download the extension from the OCI registry. You do the signature validation and validate the contents. And then you just move the entire directory into the path where you want it to be, because it already has all the predefined subdirectories for knowing where to find the files you need for your extension. We can use the identical pattern then for Cloud Native Postgres. We'd mount the image volumes for each extension inside the extension search path. So you have one extension search path, or two, as you need, /extensions. So you mount the volume for your Semver extension inside /extensions, and boom, you're done. As I said there. Again, setting aside shared preload libraries and convincing Kubernetes to allow image volume, not to require image volume on start, which is probably a big lift, honestly. So that's kind of the approach I was taking in a proposal I made last year. I still think there's something there, and I like to see it evolve and through further discussion with the community as much as possible. But now let's talk about fun with dependencies. As I said, often when you're installing extensions, you need to install other dependencies that require that are not part of the extension. So packagers manage these, of course, through normal means. They make them a dependency of the package itself. But can we genericize this for the trunk format? I imagine two approaches, right? One is that we have the list of dependencies in the metadata file, and the command line client knows how to install them from its packaging system. And we did a brief prototype of this at Tembo, where we built a library to know, okay, on my Mac OS, I'm going to try and install dependencies from Homebrew. I'm on Debian, I'm going to try and install them from PGDG or just apt. So that's fine for being able to dynamically install dependencies. The other option then is to actually bundle dependencies. And in this way, you just include the library you need in the library directory in your trunk file, and then it gets installed as part of the package. Another option would be to have, if a dependency is shared by lots of different extensions, maybe there's another trunk that just has that dependency, and they declare a dependency on it, right? The latter, of course, is required for the image volume immutability. Packaging dependencies are loaded by the OS, right, through dynamic libpath. So I'm going to talk about the Linux, the way it works on Linux here. I think it's pretty similar elsewhere. LDconfig caches the locations of all the installed shared libraries. And this is perfect for package solutions, because if you install PostGIS from PGDG, it knows what the dependencies are and installs those libraries. It runs LDconfig, it updates its cache. But this isn't going to work for immutable systems, because you can't install, of course, the shared library into these immutable directories that are elsewhere in the system. And you can't run LDconfig. Well, excuse me, you can, if you mount it on a mutable directory, and this is something I was working on at Tembo, you can run LDconfig for the library that you put it in on a persistent volume, but it can't write to the cache, which lives in the immutable part of the container. So the idea here was to install the dependent libraries directly into the package with the extension module, and compile Postgres with a run path to that directory. So the run path is a way for the system to resolve the dependencies without having to depend on the cache, because the binary itself knows this location, and it becomes the first or third place that it looks for dependencies. So there's no need for LDconfig caching. It doesn't consult a cache when it's looking files up in the run path. And run path is supported by most operating systems. There's a nice post here from quite a while ago about rpath and runpath and how they're supported in various OSs. So here's an example. Change rpath is a little utility that's on Debian or Ubuntu. So if I run it on Postgres itself, this is one I built for Tembo. It shows that, okay, here's the typical package libdir that's compiled into Postgres itself. And then here's an additional directory where I'm going to put modules. All right. And in this example, I had them on a shared volume. So if I look at the contents of that, I can see here, okay, I'm installing the URI extension, which depends on libURI parser. So I also have the shared libraries for libURI parser in that same directory. So let's look at the run path for the extension module, uri.so. It also has a pointer to that directory so that when it loads this this module, the OS then knows where to look for additional dependencies. And I can tell that it works when I run LDD against the module because it shows me it's resolving each of these dependencies, including libURI parser. It finds it in this directory where I put it. So cool. And this actually works. I can, as long as I have my dynamic library path set to point to this directory, and I've done a little fiddling with the extension because due to a documentation oversight in Postgres 9.1, everybody says $libdir / extension name. That only works for the libdir part. It doesn't work for any additional stuff in the path, so you have to strip that out. Everybody should, I think, just do that now for their extensions. But having done that, it works. It finds the dependency and will run the extension correctly, and I can use it. You can also use rpath origin, which means look in the same directory in which I live. I need to speed up here a little bit. This is supported by all major Unixes. It's called loader path on Darwin. It's not supported on Windows, unfortunately. But if you use origin, so if I replace that run path I had in the module with origin, you can see it's setting it now to origin. It still continues to work and find the dependency I need. If I change it to something else, you're going to see it's not going to work. Can't find it. So the idea here is you extract dependencies from the OS packages, you put them in the trunk lib directory, you compile the extension with origin, and here's how you do that. And the Postgres itself doesn't even need the rpath, it's built into the module. So does this work? Yes and no. So I tried to do this with the PGSQL HTTP module, and you can see I have the run path set to origin here. And when I run LDD on it, it says, okay, I need libcurl. So I'm like, okay, let's install libcurl. I copy it from another system and put it in there. I run LDD again. Does it work? Okay, I've got libcurl. Great. Now libcurl depends on other stuff like libng httpt2. So I'm going to, and a bunch of other stuff. So I copy that module from another system, and it should be good to go, right? No. It doesn't find it, even though it's there. So the issue is that a run path does not cascade from the top binary all the way down. It's only from the binary to its immediate dependencies. If those dependencies depend on other dependencies, it can't find them unless they also have a run path. So it only works for directed dependencies. There might be some way to do it. Maybe we then have to compile the dependencies with our own run paths. You can replace run paths. I was using change run path to do that, but only if there exists a run path and you don't make it any longer. And most of them don't have run paths. So we can't copy OS packages unless they start using the run path. But meanwhile, we could bundle direct dependencies like the URI stuff. So currently, the vision remains intact. I'd still like to do it. I want accessible, easy to install extensions everywhere. Close to finishing like a V1 of the SDK. To support PGXN and PGRX. First deliverable will be a new command line client. This work will inform the RFCs because I'm sure I'll find other patterns need to address to update them. So want to finish that work. I want to develop and submit the extension search path patch and see how well hackers likes it. See if we can get Kubernetes to change the behavior of image volume. And start building and distributing OCI trunk packages to make the pattern available for distributed registries. So you could build your own. If you have an extension, you can build your own trunk. You don't have to be fully located. And then hack this support into Cloud Native PG. If this is something you'd like to help with or help me help with, let's talk. And that's my talk. Thank you so much for listening.